Reaction rate factors is our last video in our video series reviewing the concepts so far presented in Cool Chemistry Show for your first 6-week test. And this is the activity we did just before spring break here. And so we're going to review it real quick here. What I want you to be able to do by the end of this is you should be able to apply the 4 reaction rate factors to real-world situations. You not only need to know what they are, but how to apply them. And that's what you're going to be tested on. So pay attention and work through these examples here. There are 4 of them. Our first one is going to be concentration. And so what concentration is looking at is how much of something there is in a given area. The more concentrated something is, the more likely you are to have a reaction take place. If you were to think about this, this is like the idea of having 2 bumper cars on a football field. And the likelihood of them running into each other if you were to blindfold the drivers is probably not very much. Okay? But if you were to add 1,000 other bumper cars to that same field, you're more likely to run into somebody than with just that one car. It's more concentrated having those 1,000 bumper cars on the field rather than just 2. So the more concentrated something is, the more likely you're to have a reaction. And this works in chemistry too. The more concentrated your reactants are, the more likely that they're to come in contact with each other and create products. Temperature is something that you're familiar with. Okay, the hotter something is, the faster those molecules are going to move, and the faster they're moving, the more likely you are to get a collision. And our example here is if you have a piece of ice, those molecules aren't moving very fast, okay? And if you were to use that piece of ice to make tea, it wouldn't make tea very fast. But if you were to heat up a pot of water instead and make tea with that, those water molecules are moving a lot faster. They're bouncing off the walls of the pot, and so as soon as you put that tea in there, it's going to work. It's going to react a lot faster, and it's going to draw out that tea and make you a pot of tea than the ice would on its own. Our third reaction rate factor is that of surface area. Now, surface area has to deal with the exposed area on an object. So here I have a sugar cube, okay? And if you imagine the sugar cube as a 3D object, the only way that anything can react with it is along the surface, okay? If you were to pick up that sugar cube with your fingers, the only thing you're coming in contact with is the surface. The same thing is true for any liquid that you put that sugar cube into. Alright, the first thing that's going to react with is the surface of that cube. And so it's going to start by dissolving the surface of the cube and work its way further into the sugar cube. And so we'll draw some additional arrows here to show you that that is the only place that can take place. Now, if you take a granulated sugar or a powdered sugar, which you're more familiar with here, the molecules of sugar are a lot smaller, and so there's a lot less material on the inside that's not exposed. Okay, so you get a lot more surface area for each of these sugar molecules than you do if you had used a cube of sugar. So anytime that you can use a powder instead of a solid, it's going to react a lot faster. Alright, so if I have a solid piece of magnesium and I drop that into hydrochloric acid, it's going to react. But if I took that same amount of magnesium in a powder form and dropped it into the same concentration of hydrochloric acid, it's going to react a lot faster. Okay, so surface area, the more of it you have, the faster the reaction is going to be. Our last reaction rate factor is that of a catalyst. And when we're talking about catalysts, we're going to talk more about this in the next unit here, in our unit on digestion. But what a catalyst is, it's a chemical that you can add to a chemical reaction that speeds up the reaction without being used, but it's specific to that reaction. So we looked at one where we added manganese dioxide to hydrogen peroxide and sped up that reaction. If you add manganese dioxide to any other chemical there, though, it's not going to have that same effect. It's not going to work as a catalyst. And And so catalysts are used specifically to speed up reactions. Alright, this is our last video on Monday. Remember, we're going to have a test over these packets. Some of that material directly from the packet is going to show up on the test, so you can use your packet on Monday. And have a good weekend, and I will see you on Monday.